The first question says if the sum of two numbers is 1215, right, and their HCF is 81, then the possible number of pairs of such numbers. So, I have to find how many such pairs are possible, right? So, the HCF of two numbers is 81. That means highest common factor is 81, right? So, if you have to represent one number, right, say the first number you can represent it as 81x, and the second number can be 81y, right? Because this was the highest number that was common between the two terms, right? And x and y can be any co-prime number, right? That has nothing to do in common, right? So where x and y are co-prime numbers. So this is how you have to write. So let the first number be 81x and the second number be 81y, where x and y are co-prime numbers. It is given that the sum of the two numbers is 1215. So 81x plus 81y is equal to 1215. Right, so you can take 81 common between these two terms. So 81 x plus y is equal to 1215. Right, so the value of x plus y is 1215 upon 81. Right? So now you have 1215. Okay, so 81 ones are 81, 0, and then you'll get 4. So 405, and then 81 5s are 105, 405, right? So this will be 15. Okay, so you'll get 15. That means x plus y. So there are two co-prime numbers whose sum is 15. Right? This is how you'll get the number. So then you can find possible combinations like x can be 1, y can be 14. Right? So this is one possible combination. Then x can be, if you take x as 2, y can be 13. Right? If you take x as 3, then y will be 12, but 3 and 12 are not co-prime, so that is incorrect. If you take x as 4, then y would be 11. If you take x as 5, y will be 10, which is again not correct, right? Because they are not co-primes. If you take x as 6, then y will be 9. Again, they are not co-primes. Take x as 7, so y will be 8, right? Then if you take x as 8, y will be 9. So the same thing is going to repeat over and over again, right? So how many pairs are there? 1, 2, 3, 4. So you get 4 pairs. Okay. Wow. You don't have 4 in the option. The only way in which you can get 7 is, I mean, you then start counting in reverse order. Say x is equal to 8, y is equal to 7. Still you'll get 8, and then maybe you can just drop this 1 and 40 once. Right, but I don't think that is a feasible solution. So I think ideally you should have 4 pairs only. If 3 is the least prime factor of number A and 7 is the least prime factor of number B, then the least prime factor of A plus B is. So see, if 3 is the least prime factor of number A, so you know that 2 is the, 2 is the only even prime number, right? So if 3 is the least prime, so that means the number must be odd. Because if that number has, say, something, so if you find some power that is higher than 2, some number that is higher than 2, or that is even as the factor of this number A, right? Say 4. First of all, you won't be able to find any prime number, even if you find a composite number. So it will again come down to 2 as a prime factor. So 4 will have 2 as a prime factor. But it is given that 3 is the smallest prime factor. Right? So if 3 is the least prime factor, that means the number must be odd because 2 is the only even prime number. Right? So A is odd. So you can write A in the form of 2n plus 1. where n belongs to integer, right? 7 is the least prime factor of number b. Again, 7 is, b is also odd. So you can write 2m plus 1, right? So this m and n can change, right? They can have different values. For example, here n can be, say you can take n as 4, right? So when you take n as 4, the number will be 9. So you can see 3 is the least prime factor of 9, right? This, you can take, say, a number, for example, 49. So you try to make this 49. So this will be 24, right? So then b will become 49, for which 7 is the least prime factor. So they need not be equal. So that is why I've given different values, n and m, right? I could have given n and n, that would have made it more simpler, but we have to use different variables because the values may be different. The same value of n may not satisfy this value. So 4 will not satisfy here, right? Because you know that 7 is not a prime factor of 9. Okay. Then the prime factor of a plus b is, right, least prime factor. So a plus b, you'll get 2n plus 1 plus 2m plus 1, right? So 2n plus 2m plus 2, right? So then if you take 2 common, you'll get n plus m plus 2. So no matter what n is, what m is, this will always be a factor of 2, right? So you know that 2 is the smallest prime number. Yeah, yeah, to be 1. Sorry, this is 2 and this will be 1, right? So no matter the value of n plus m plus 1, this will always be even, right? This number. So that means the smallest prime factor will always be 2, right? Okay, another controversial question. Uh, Ajay wants to host a party on his 50th birthday in a large banquet hall having a certain number of chairs. He wants that guests should sit in different groups, like in pairs, triplets, quadruplets, fives and sixes, etc. When the banquet hall manager arranges chairs in such pattern, like in twos, thirds, fourths, fifths, and sixths, then 1, 2, 3, 4, and 5 chairs are left respectively. But when he arranges in groups of 11, no chair is left. What does this question mean? So there's a guy, Ajay, he wants to celebrate his party, right? So he's arranging chairs for that, right? And then when you make arrangements, for example, this can be the stage, right? The main stage. And then you can have chairs, arrangement of chairs like this. So you can make it in groups of 2 like this. You can put 2 chairs together, right? Or you can make 3 chairs together like this, right? So this is how you make groups of chairs. So he gave this task to the hall manager. So what he saw or what he observed is that if he is making groups of 2 like this, he'll have 1 chair left, right? If he is making groups of 3 like this, then he has 2 chairs left. 4, he has 3 chairs left. For 5, he has 4 chairs left. And for 6, he has 5 chairs left, right? So if you make groups of 6, so after making that groups of 6, you'll have 5 chairs left for which you won't be able to create any group, right? Is this question clear? What is this trying to say? Okay, fine. Now, and then he also noticed that when he arranges them in groups of 11, there is no chair left, right? So that means if you create groups of 11 chairs, there won't be any chair left without grouping, right? So 11 chair is the most optimal arrangement in which you can use all the chairs. Now the question says, how many chairs are there in the banquet hall? This is the first question. So start by assuming, let the number of chairs in the banquet hall be x, right? So we are assuming let the number of chairs in the banquet hall be x. Now I'm noticing that if I make groups of 2, I have 1 chair left. If I make groups of 3, I'll have 2 chairs left. If I make groups of 4, I'll have uh, 3 chairs left. If I make groups of 5, I'll have 4 chairs left, and so on. Right? So why don't I just add 1 chair? Right? Once I add this chair, what will I see? If I make groups of 2, then previously 1 chair was left. Now there will be 2 chairs left, so I can make that group of 2. So there will be no chair left. Right? If I make groups of 2, earlier I had groups of 3. Earlier I had 2 chairs left. Now I'll have 3 chairs left, which can be created in a group. For 4 also, I can see I can create a group now by adding 1 chair. For 5 also, I can create a group. And for 6 also, I can create a group. Right? So if x is the total number of chairs in the banquet hall, so x plus 1 must be a factor of 2, yeah, 2, 3, 4, 5, and 6. Yeah, so I'll come to that later. So first of all, we want to see what x plus 1 is, right? So that means x plus 1 must be equal to some multiple of this LCM of these numbers, right? So what is the LCM of 2, 3, 4, 5, and 6? Okay, so the LCM of 2, 3, 4, 5, and 6 is 60. So this is equal to 60. So x plus 1 is not 60. X plus 1 must be a multiple of 60. So it can be 60k, right? Where k belongs to natural number. K cannot be an integer here. Why? Because number of chairs cannot be negative, right? So x plus 1 is 60k. So this is the first thing that we got. Or we can say x equals to 60k minus 1. Right? Now we know that x is also equal to 11m for some m belongs to natural number. Why? Because I have assumed that x is number of chairs. And it was given in the question that if you are arranging in group of 11, so there is no chair left. So x is a multiple of 11. So I'm writing x equals to 11m for some m belongs to natural number. Again, m will not be an integer in this case. Right? So that means 11m must be equal to 60k minus 1. Right? Any question? Then m is equal to 60k minus 1 upon 11. Right? Now we know that m must be a natural number. So they too must be, this must be a factor of 11. Multiple of 11. Right? So we can further simplify this. So see, this is 60k, very large number. So I can write this as 55k plus 5k minus 1 upon 11. Right? So I can write m is equal to 55k upon 11 plus 5k upon 11 5k minus 1 upon 11. Right? So this I already got as 5k, which is an integer. So I'll stop worrying about this. Right? Sorry, not an integer, but a natural number. Now I'll have to worry about this. So 5k minus 1 upon 11 must be a natural number. Right? Now, which means that 5k minus 1 must be a multiple of 11. Right? Now, when is this a multiple of 11? Now, since I have a smaller number, I can just substitute values for k to see what is the possible value for k wherein this number will be a multiple of 11. So you can say for k equals to 1, it will not be 0. So we'll start from 1. This is not a multiple of 11. For 2 also it will not be a multiple of 11. For 3 also it will not be a multiple of 11. We'll keep on checking. Finally you'll reach a value, for example, 9. So if you substitute that value 9 here, so you'll get 45 minus 1 upon 11. So this will be equal to 44 upon 11. That is equal to 4. Right? So k is equal to 9 is one of the values which satisfies this. Right? But I am not sure whether this is the only value. So I have to write a generic form. Right? So what I can do? So I can write this as, so this is 9. So I can write k as 11, say p plus 10. Why I'm writing, I'm taking help from 11p because this will ensure that this is a multiple already of 11. So this will get cancelled. Now this 9 is what I'm getting from here. Right? So k is 11p plus 9. So again, this is one more variable that has come into picture. So we can write 5 times 11p plus 9 minus 1 upon 11. So this is the value of m. Right? So then this will be 55p plus 45 minus 1 upon 11. Right? So what is the value of this? This will be so that is 44. So 5p plus 4. Right? So this is an integer. So I can say that for k equals to 11p plus 9, this will come out to be an integer. I mean, not an integer, but a natural number. So I got the value of k. Right? Now coming back to this. Right? So we already know x plus 1 is 60k. Right? Or x is 60k minus 1. So, and k is 11p plus 9. Right? So all this thing we did just to find the value of k. So we'll just substitute this 11p plus 9 instead of k. So 60 times 11p plus 9 minus 1. So this will be equal to 660p plus 540 minus 1. So this is the value of x. So the value of x or the number of chairs are 660p plus 539, where p is, here I don't have any constraints on p. So it can be a whole number as well. Why? Because we already had this 9 here to take care of the case wherein, so p cannot be negative, but it can be 0 here. Right? So, I mean, the smallest value of p now will substitute as 0. Right? So p can be 1, p can be 2, p can be 3. So any value of this will satisfy this condition, whatever they have given in the question. So if I substitute p as 0, I'll get x equals to 539. So this is the answer. Okay. Now, number of chairs in the banquet hall is 539. If 3 chairs are removed, then the remaining chairs can be arranged in groups of. Right? Okay. So this is where it gets confusing. So till this, the approach was quite clear. We had just one approach. Now the question says if you remove 3 chairs, so you'll get 536. Number of chairs are 536 now. Now then the remaining chairs can be arranged in groups of. So you just have to check out of these 536 is a factor of which of the following. So it is a factor of 2 because it is an even number. Is it a factor of 3? So you just add the numbers. 5 plus 3 is 8, 8 plus 6 is 14. Right? So it is not a factor of 3. So first of all, 2, it can be arranged in groups of 2. Then we need to check for 4. So the last 2 digit is a multiple of 4, so it is a factor of 4. So 4 can be also true. Then we'll check for 6. Since it is not, divisible by 3, it will not be divisible by 6 as well. So only 2 and 4. Right? Now you can see they've given both as the correct answer. Right? So any one of this can be correct. Ideally, both of this is correct. Right? Obviously, you'll not get such kind of question in the board's exam, wherein you have two same answers. Right? Otherwise, everyone will get the same marks. Okay. If one chair is added, then the total number of chairs that can be, can be arranged in groups of. So we have already seen if you just add 1, it will be a multiple of all this except 11, right? So 2, 3, and 4. If one chair is added to the total number of chairs, how many chairs will be left when arranged in groups of 11? Yeah. Earlier it was a factor of 11. Now if you just add one chair, it will have a remainder of 1. How many chairs will be left in original arrangement if some number of chairs is arranged in groups of 9? So you already have this. So if you create groups of 9, so the number of chairs was 539. You just need to find the remainder when this is divided by 9. So 9 5s are 45. And then you have 89. So 9 9s are 81. So 8. So 8 should be the answer. Any question? Did you get this approach, how we solve this? Okay. Statement 1, for any positive integer n, n cube minus n is divisible by 6. Right? And then, so this is the assertion. Reason says product of 3 consecutive natural numbers is always a multiple of 6. So if you just solve for this, n cube minus n. Take n as common. So you'll get n square minus 1. This will become, so if you apply the formula, so you can write n square minus 1 square. So what is a square minus b square? It is a minus b times a plus b, or a plus b times a minus b. So this will become n times n square minus 1 times n square plus 1. Sorry, this will be n times n minus 1 times n plus 1. So if we just arrange it in ascending order, we'll get n minus 1, then n plus 1. Right? So these are 3 consecutive natural numbers. Right? Why consecutive natural numbers? It is saying for any positive integer n. Right? So you have 3 consecutive natural number. Now, take any 3 consecutive natural number. One must be odd, the other must be even. Right? So it will always be a factor of 2. A multiple of 2. Right? No matter what value you take, it will always be a multiple of 2. Then comes, for a number to be divisible by 6, it must be divisible by 2 and 3. So we know that, if you have 3 consecutive numbers, one must be odd, the other must be even. So this is, we are sure. The third one, we cannot say, it may be odd or even. Okay, now think about 3 consecutive numbers. Okay, you have n plus 1, n plus 2. So say n is not a factor of 3. Say first case is n is a factor of 3. Okay, so then this entire thing will be a factor of, say n is a multiple of 3. Right? So this entire thing will be a factor of 3. So if 3 is a factor of n, so 3 will be a factor of all of this. So we're discussing about this consecutive natural number. So say when we have 3 consecutive natural numbers, one must be odd, the other must be even. So this 2 is sorted. So, I mean, it will always be a factor of 2, no matter what the number is, right? The 3 consecutive number. Then, I mean, just take 3 numbers, right? Let this be n minus 1. Right? We'll take 3 natural numbers, n minus 1, n, n plus 1. Okay, so there can be 3 cases. Pick any number. Say, we can start with n minus 1. So if n minus 1, so there can be 3 possibilities. Uh, First possibility is it is a, I mean, 3 is a factor of n minus 1. That means 3 will be a factor of all 3 numbers. Right? So which means 2 and 3 will be a factor of this, which means 6 will be a factor of this. The other case is 3 is not a factor of n minus 1, then it must leave some remainder. Right? So what are the possible remainders? It can be either 1 or 2. So when the remainder is 1, so if I just add 1, it will be a factor of 3. That means if n minus 1 leaves a remainder of 1 when divided by 3, that means n must be a factor of 3. Right? And then when n minus 1 leaves a remainder of 2 when divided by 3, so then n plus 1 must be a factor of 3. I mean 3 must be a factor of n plus 1. Because we are just adding 2 to that. So that remainder part will be gone. Right? So, I mean, I told you the opposite thing. So if it is 1, so we have to add 2. So this will be n plus 1, right? If the remainder is 1, we have to add 2. So it will become n plus 1. And when the remainder is 2, we just have to add 1. So it will be n. Right? So no matter what the numbers are, if you have 3 consecutive numbers, 1 will always be a factor of 3. And one of that will always be a factor of 2. Right? So that is why we can say that this will be a multiple of 6. Right? And the second statement says what we have just proven. Product of 3 consecutive natural numbers is always a multiple of 6. So both of these are true and this is the correct explanation.